Now, there's a lot of different aspects of rational functions that are important, but one of the features that's critical if you're wanting to understand the behavior of a rational function and specifically how to graph it, one of those things is asymptotes. And so we're going to talk about the definition of an asymptote. Now, there are two types of asymptotes that we're going to talk about here. We've got vertical asymptotes and we've got horizontal asymptote. So here's the definition. I'm going to read through the definition and then give you just a little picture of what this means. So first, the line x equals c is a vertical asymptote of the graph of y equals f of x if y increases or decreases without bound. And that's the key right there, without bound, okay? Meaning it's going off to infinity or negative infinity, as x gets closer to c. So we get closer and closer to this line. As x gets closer and closer to this line, our y value gets bigger and bigger or smaller and smaller. In other words, y approaches positive or negative infinity as x approaches c from the right, meaning x is really close to c, but bigger than c, or here x approaches c from the left. For a horizontal asymptote, we have a line y equals c, and it's a horizontal asymptote of the graph of y equals f of x if y gets closer to c, okay, this line here, this horizontal line, as x increases or decreases without bound. So again, that same expression, without bound, and all we're saying here is that x is going off to infinity or negative infinity. So as x gets bigger and bigger and bigger and keeps growing, then our y value approaches some number. Let me just draw a quick picture of these two things so you can see what they look like. So we'll just draw one graph here. And we'll start with our a vertical asymptote. And so a vertical asymptote is a line, x equals c. So wherever it is, let's just pretend that this is c right here. And we generally denote these asymptotes when drawing them with a dashed line because the line itself isn't actually part of the graph of the function, but it's a line that is significant in relation to the behavior of the function. And we say that this is a vertical asymptote if y increases or decreases without bound as x gets closer to c. Okay, so whatever our x values are, maybe we're bigger than c, but and x could do anything it wants over here. Okay, but as we get closer and closer to c, our y value needs to, here it's increasing without bound. Okay, it's just going to go up and it's going to shoot upward to positive infinity. Okay. And on the left side, we could have the same idea. We could have something that is, does whatever we want it to do. But then, as we get closer and closer to c, here on the left side, then our y value here is decreasing without bound. Okay, so here, this portion of the graph, that portion of the graph right there, this is what we would call, this is y goes to negative infinity as x is getting close to c. And then the superscript of the negative means from the left, meaning x gets close to c on the left. And over here, okay, this portion of the graph, that is saying that's y approaches a positive infinity as x approaches c from the right. Now, both sides could both go up. One could go up and one could go down. Both could go down. Doesn't really matter. As long as we have something shooting off towards infinity or negative infinity, then that's what we call a vertical asymptote. You'll notice this or, okay? It doesn't actually have to be both of them. It turns out that for rational functions, it will be both. However, in order to have a vertical asymptote, it could just be one of these, either the right side or the left side. Okay, let's talk about horizontal asymptotes. Let's just look at that real quick and what that looks like. And so now this is a y equals some number. And so this is, maybe we're down here. Maybe this is at c. Okay. And again, with horizontal asymptotes, we generally draw it as a dashed line. So this is our y equals c, horizontal asymptote. And this says that it's a horizontal asymptote if y gets closer to c as x increases or decreases without bound. So that means as we could be doing anything we want in the middle, okay? But as x grows and grows and grows, we get closer and closer to that, and that gives us a horizontal asymptote. Now, one interesting thing about horizontal asymptotes is we actually can cross the asymptote, okay, if you want. In fact, you can cross it as many times, and you could even do this little oscillation where you go around. Let me go ahead and extend this out a little bit. Okay. We can just oscillate around it, getting closer and closer. All right, and that would also make it a horizontal asymptote because y is getting closer to c, okay, as x here decreases without bound. So again, as far as these portions of the graph, okay, this one right here is y approaches c as x approaches negative infinity. And this portion of the graph over here is y approaches c as x approaches positive infinity. Because as x grows and grows and grows and grows, our y value gets closer and closer.